Welcome. Let's dive into this explainer and see exactly how wind turbines survive incredibly extreme natural forces. You see, wind is their fuel, but a 90-kilometer-per-hour storm, that's a deadly threat.
The spinning rotor catches that wind, funneling massive raw torque right into the central gearbox here.
Crazy enough, this gearbox takes that slow, sweeping rotation and literally multiplies its speed by 70.
So, how does it spin? Air splitting over the blade creates a low-pressure zone, generating massive lift.
This upward lift vector actually pulls the massive blades, creating continuous momentum to spin that heavy rotor.
But without strict regulation, high winds cause catastrophic overspeed, totally tearing those internal mechanics apart.
One clever defense is aerodynamic stall. Turbulent vortices actually disrupt the airflow, passively killing lift to stop acceleration.
Pushed past a critical angle, lift just drops off a cliff, acting as a natural, invisible aerodynamic brake.
Then there's active pitch control. The blades literally rotate on their longitudinal axis to spill any excess wind.
By turning into a feathered position directly facing the wind, they actively degrade their own power capture.
An electronic controller constantly adjusts this pitch using hydraulics, keeping the power output perfectly steady and safe. During intense winds, power generation safely flatlines, deliberately dropping all the way to zero at max storm speeds.
But what if sensors detect absolute maximum speed? Well, the final line of defense triggers immediately. A rapid chain reaction engages the mechanical braking system, pushing hydraulic pistons to create immense stopping friction. As a last resort, a massive mechanical disc brake violently clamps onto the shaft, completely halting the rotor.
Smaller turbines actually survive by physically tilting backward on springs or pivoting their rudders out of the wind.
Ultimately, mastering these violent forces is exactly what makes high-performance, reliable wind energy a reality today. So if machines can tame these chaotic winds, what other violent natural forces will advanced mechanics conquer next?